各位同学，接下来我们再来讨论一下这样一套练习当中的最后一篇文章，一篇天文学的文章。
Listen to part of a lecture in an astronomy class.
Now, astronomy didn't really balloon into the science it is today until the development of spectroscopy. Spectroscopy is basically the study of spectra and spectral lines of light, and specifically for us, the light from stars. It makes it possible to analyze the light emitted from stars. When you analyze this light, you can figure out their distance from the Earth and identify what they're made of, determine their chemical composition. Before we get into that, though, it's probably a good thing to back up a bit. You all know how when you take a crystal prism and pass a beam of sunlight through it, you get a spectrum, which looks like a continuous band of rainbow colors. The light that we see with our human eyes as a band of rainbow color falls in the range of what's called visible light. And visible light spectroscopy is probably the most important kind of spectroscopy. Anyone want to take a stab at the scientific term for visible light? And I'm sure all of you know this because you all did the reading for today.
Optical radiation. But I thought being exposed to radiation's dangerous.
Yes and no. If you're talking about radiation, like in the element uranium, yeah, that's dangerous. But radiation as a general term actually refers to anything that spreads away from its source. So optical radiation is just visible light energy spreading out. Okay, so we've got a spectrum of a beam of sunlight, and it looks like the colors bleed into each other. There are no interruptions, just a band flowing from violet to green to yellow to... you get the idea. Well, what happens if the sunlight spectrum is magnified? Maybe you all didn't do the reading. Well, here's what you'd see. I want you to notice that this spectrum is interrupted by dark lines, called spectral lines. If you really magnified the spectrum of the sunlight, you could identify more than 100,000 of them. They may look kind of randomly placed, but they actually form many distinct patterns. And if you were looking at the spectrum of some other star, the colors would be the same, but the spectral lines would break it up at different places, making different patterns. Each pattern stands for a distinct chemical element, and so different sets or patterns of spectral lines mean that the star has a different chemical composition.
So how do we know which spectral patterns match up with which elements?
Well, a kind of spectroscopic library of elements was compiled using flame tests. A known element, say a piece of iron for example, is heated in a pure gas flame. The iron eventually heats to the point that it radiates light. This light is passed through a prism, which breaks it up into a spectrum, and a unique pattern, kind of like a chemical fingerprint of spectral lines for that element, appears. This process was repeated over and over again for many different elements, so we can figure out the chemical makeup of another star by comparing the spectral pattern it has to the pattern of the elements in the library. Oh, an interesting story about how one of the elements was discovered through spectroscopy. There was a pretty extensive library of spectral line patterns of elements, even by the 1860s. A British astronomer was analyzing a spectrograph of sunlight, and he noticed a particular pattern of spectral lines that didn't match anything in the library. So he put two and two together, and decided there was an element in the sun that hadn't been discovered here on the Earth yet. Any guesses about what that element is? It's actually turned out to be pretty common, and I'm sure all of you know it. Okay, let's try something else. Any of you happen to be familiar with the Greek word for sun, by chance?
Something like Helios, or something like that. Oh, it must be helium. So you're saying that helium was discovered on the sun first?
Yes, and this is a good example of how important spectroscopy is in astronomy.
这篇文章呢是一篇难度相当大的文章，相信大家在听的过程当中，经常会有一种较强烈的挫败感。但怎么说，这种文章的话呢，在考试当中是有可能出现的，所以也就请大家能够提高自己的这样一个抗挫力，对吧？也就是这篇文章当中，其实具体讲到的内容呢，就是光谱分析的问题。而这里的为了帮助大家理解，对吧？大家会发现考官在文章展开的过程当中，还要给大家提供这样一个图片，而这个图片呢，就是告诉我们有个 spectral line， 有个光谱线，然后其中有些地方有黑线，这里大家也都看到了。那么它最大的难点就在于其中会存在一些专业性的术语，但实际上对于专业术语的话呢，教授往往会进行解释。应该大家会记得我们前面讲过一篇 film history 电影历史的这样一篇文章，其中提到一个词 hybrid， 这个词的话，教授立马有解释，它的意思是 mixture。对吧？所以如果遇到这种较大难度的文章，大家不要被词汇吓倒，你要去仔细的去听文章当中的定义细节，对吧？而出题点的话呢，无非就是围绕文章当中的每一个 subtopic 来出题。当然，首先第一题的话呢，还是一个主旨性的题目。What is the lecture mainly about？ 4个选项 ，A 选项，不同的方式用来扩大光谱，这个扩大一颗星球的spectrum， 对吧？然后 B 选项 ，How a chemical element was first discovered on the sun， 对吧？如何在太阳上首先发现的一种化学元素。C 选项 ，How astronomers identified the chemical elements in a star， 天文学家如何去确定一颗星球的化学物质组成。然后 D 选项 ，Why the spectra of different stars are composed of different colors？为什么不同的星球的这个光谱是不同的颜色，对吧？那么具体选择哪个概念，咱们说文章开头部分的语言，这是重中之重。我们听到的语言 ，Now astronomy didn't really bloom into the science it is today until the development of spectroscopy， 对吧？在光谱分析出现之前，天文学一直来说都还是没有完全发展起来的，对吧？所以这篇文章呢，重点讲到的就是光谱分析的问题，然后又提到对于 spectroscopy 的解释 ，as basically the study of spectra and spectral lines of light， 对吧？它研究的就是什么呢？研究的就是 spectra and spectral lines of light， 对吧？研究的就是光谱线、光谱和光谱线 ，the light from stars。And specifically for us, the light from stars. 所以什么叫做 spectral lines of light？ 也就是 the light from stars， 有一个解释，对吧 ？It makes it possible to analyze the light emitted from stars. When you analyze this light, you can figure out their distance from the Earth. 那么通过这个研究，我们能够得出什么结论 ？And identify what they are made of, determine their chemical composition. 能够决定它们的，能够判断出来它们的化学组成，这些都是光谱分析给我们带来的好处。那这其中的话呢？我想大家笔记当中应该能够记录下来的内容就是有一个 distance 和一个 chemical composition， 所以这篇文章的引出的方式就是引出一个概念，然后主要围绕这个概念来展开，对吧？那下面的话4个选项，那当然就是选择 C 选项 ，How astronomers identify the chemical elements in a star？ How 呢？答案就是 spectroscopy， 对吧？所以对应上 C 选项，也就是 C 选项当中虽然没有 spectroscopy 这个词，但是的话，它的意思已经在这个选项当中包含出来了，已经展现出来了。而 A 选项虽然有 spectrum 这个词，对吧？但是它说的是 magnifying 扩大，这个肯定就不对了，对吧？所以它其实是 a way， 然后这种方式的话就叫做 spectroscopy， 这其中存在一定的换词，所以像这样的选项的话，那就请大家要稍微注意一下了，对吧？好，这是第一题，这个概念我们清楚了。研究这个的好处就在于能够帮助我们判断这些，也就是说，文章一开始把主题、这种科技以及这种科技的结果都已经告诉我们了，对吧？然后下面第2题 ，What does the professor explain to one of the students about the term radiation？ 对于其中的这样一个术语 radiation， 所以这里面就存在了很多术语，一个术语是 spectroscopy， 另外一个术语 radiation 辐射。对于这个，教授是怎么说的？4个选项。对吧？然后这一部分大家并不是让大家回答 radiation 这个词是什么意思，而是说教授对这个有什么说法。那么对于术语部分，我们要注意它的这样一个表述。我们听到 yes and no， 又是又不是， 首先要注意的就是这个概念，这个在笔记当中一定占据非常重要的地位。那么接下来就有教授对这个概念的一个具体的解释。If you're talking about radiation like in the element uranium, yeah, that's dangerous. 一方面它是危险的，这个肯定有听得到。如果讲的是铀，那就是危险的。But radiation as a general term actually refers to anything that spreads away from its source. 实际上，这里我们听到一个 but， 也就是说，教授具体讲的就是在另外一部分情况下，它是不危险的。就实际上我们生活当中接触到的所有的物体都会释放出辐射，不能说辐射一定是危险的。So optical radiation is just visible light energy spreading out， 对吧？好，那么这样的话呢，这个概念听清楚了以后，4个选项当中到底哪个有包含既是又不是这种概念呢？ D 选项 ，It does not refer only to harmful energy， 对吧？并不完全指的是有害的能量，对吧？那这个就能够判断出来了。注意表达方式的转换，对吧 ？OK， 这是第2题。注意它这样一种 paraphrase 的方式，对吧？好，下面第3题。What can be inferred about two stars if their spectra have similar line patterns？如果2颗星球有相似的光谱线的话，那么我们能够得出什么结论？所以通过光谱线的分析来得